Assalamualaikum and good day everyone. This is our first class for BGN 172 structure analysis, the first recorded video. So we go to the chapter 1, which is stress, strain and modulus of elasticity relationship. Okay, as the title says, stress, strain, and modulus of elasticity. So first we look at stress. We need to know what does it mean by stress here. Okay, the definition is when force is transmitted through a body, the body tends to change its shape. Okay, so any force, for example here, if let's say here I am drawing a table. Okay, this is like a table or whatsoever. Okay, if you sit on this table, okay, let's say someone stand on this table, so this table, this person is actually, the weight of this person we consider it as a force lah. Maksudnya force dia bertindak ke bawah because of the gravity, and then this table mungkin akan ada change dia akan change its shape tapi sama ada dia berubah atau tak. Okay, so we see here, although these deformations are seldom visible to the naked eye, the many fibers of particles that make up the body transmit the force throughout the length and the section of the body, and the fibers doing this work are said to be in the state of stress. So this table, fibers or the particles inside this table is actually in the state of stress. So itu maksudnya sekarang. Okay, contohnya juga, if let's say if I push you, you have to study hard, you have to work hard, you have to get A for structure. So your brain is actually in the state of stress. So I force you, you pun stress, macam tu lah. But here we are not talking about human psychology or whatsoever. Here we are talking about object. Here contohnya kat sini I bagi table lah, ataupun if let's say if we're talking about structure, here we have a column, a rectangular column. So you have beam that connected to the column that actually transmit the force to this column. So force it transmit pada this column. So this column, particles inside this column is in stress. So fibers, particles dalam dia try to maintain its shape. Jadi that's why dia dalam state of stress. Okay, thus a stress may be described as a mobilized internal reaction that resists any tendency towards deformation. Because of this column, okay, dia ada internal reaction inside that try to avoid deformation. They try to resist the deformation. So particles dalam ni bekerja keras lah. Okay. As the effect of the force is distributed over the cross-section area of the body, stress is defined as force transmitted or resisted per unit area. So if we're talking about, you have here, this is a beam that transmit the load to the surface of this what we call it, column. So area yang mana, so area dia adalah area cross section of this column. Cross section ni pecahkan tengah, so nampak masih lagi segi 4 So this is the said area area yang kita tengah refer sekarang lah. Okay, direct axial stress, tensile and compressive stress, which result from force acting perpendicular to the plane of cross-section in question, are known as normal stress, are usually symbolized with sigma. Okay, symbolized with sigma. So ejaan sigma macam ni sigma. Okay, so dia punya symbol is actually like this lah, sigma. Jadi kat sini it says that tensile or compressive stress which result from forces acting perpendicular to the plane. Maksudnya plane tu area dia lah, area surface kat mana yang the force acting on it. Contohnya macam tadi, like column like this, you have a beam and such. So the area is This one lah, maksudnya area, bukan area ni saja, bukan surface area saja, the whole area, the cross section area, the whole area of this column ni, maksudnya, tapi perpendicular bila perpendicular maksudnya 90 degrees lah. What is perpendicular bahasa Melayu? 90 darjah tu bukan selari, apa-apa je lah okay, so dia actually memang 90 degrees lah, maksudnya your force 90 darjah dengan the surface, jadi that surface is the area yang actually in stress tensile and compressive stress. Jadi it says here this is stress yang perpendicular, macam ni kita panggil dia as normal stress. Okay. However, shear stress, so here shear stress is produced by forces acting I tak boleh sebut, or tangential to the plane of the cross section and is symbolized with theta. Okay, so simbol dia macam ini. So ini namanya shear stress. So I believe that before during the part 1 you already know what is shear. Okay, you dah tahu shear tu macam mana. Jadi shear tu is force. Contohnya, if this column is subjected to the lateral forces lah. Contohnya macam wind ataupun wind lah, mostly lateral forces. So you have a force like this, which is tangential. Sorry, selari. I cannot sebut. P to the plane. Okay, so ini plane, the said plane, and then the forces is actually parallel or tangential to the plane. Okay, jadi ini kita panggil dia as shear stress. Okay, yang ini tensile atau compressive stress. This one adalah shear stress. Alright, let's move on. When a force is applied to an elastic body, the body deforms. So if let's say you have like a rubber band like that, okay, you try to stretch the band, okay, you will see that the band will deform because of rubber band is this elastic characteristic dia elastic, dia boleh bend, boleh you boleh tarik dia berubah. The way in which the body deforms depends upon the type of force applied to it. Here we have one is compression force. So right now we are talking about normal stress. Normal stress yang the first one tadi lah, maksudnya yang actually perpendicular dengan plane tu sendiri perpendicular 90 degrees tu. So first we have the compression force, and the second one we have a tensile force. So compression force, you see here, it will make the body shorter. So here, if let's say you have something like this, your object is like this lah. So if you put a force on top of it, if let's say it have elastic capacity characteristic here, elastic characteristic here, then this material ataupun this object will basically akan deform, dia akan compress dia akan shorter. Okay, and for tensile force, if you pull it out, you tarik keluar, okay, you tensionkan dia, it will make the body longer. Perhaps originally dia kat sini lah, okay, and then dia membesar, dia panjang, semakin panjang Okay. Alright, so the formula here, so right now yang kita belajar ni for this chapter, mostly we look at the tensile and compression force, okay, ataupun stress, tensile stress and compressive stress, okay. Jadi maksudnya yang ni lah sigma tadi. Okay, so stress equal to force per unit area. Okay, we know that is the formula. So stress is equal to force divided by area. So area yang perpendicular. This is the formula that you have to remember lah. Okay, inilah formula dia. sigma equal to F divided by A, which means sigma is the stress ataupun compressive ataupun tensile stress, and then F is a force, how many forces you put on the object, and A is the perpendicular area plane tu okay. Okay, stress is a load effect. Stress by definition is relationship between a force and a particular area. In order to define stress quantitatively, therefore the force, so if let's say before this you ada belajar, I'm pretty sure kalau siapa yang belajar physics, they will know what does it mean. I tak tahu lah kalau you belajar science you tahu, tapi if let's say you ever ambil physics before, you akan tahu the scalar and vector unit. Okay, so kalau vector should be dia ada magnitude and direction. Okay, jadi force tu memang ada magnitude and direction because of magnitude dia maybe like 50 kilonewton. Direction dia ke mana? Going up, going down, going right, going left. Depends on the direction. Jadi dia adalah vector unit. Must be defined, and in addition and configuration of the area in question must be defined. Jadi stress ni quantitatively dia ada force yang must be defined, in addition the configuration area in question must be defined. Maksudnya kena tahu berapa banyak force dan area yang mana yang related to it lah. Maksudnya force tu ke arah ke mana, so area mana yang terlibat Therefore, we must know the magnitude of the force, the direction, and the plane which area lies. Okay, kalau you tahu, we have like, kalau kita lukis 3-dimensional like this. Okay, so this is X, Y, and Z. Okay, 3-dimensional like this lah. Okay, which plane actually, because of kita hidup dalam dunia 3D bukan 2D. But here I only cover X and Y sajalah. Z tak adalah kita belajar Alright, and then we have the units of stress. So unit of stress, normally what we use is Newton over millimeter square. Newton per square millimeters. This one yang others ni is tak salah. You boleh pakai kilonewtons per square meter, meganewtons per square meter. Doesn't matter. It's okay. Tapi this is actually macam standard lah. Normally kita akan pakai Newton over mm square. That is the units yang we usually use. Alright, so we go to the example number 1. This is a simple example just to give you basic understanding. A bar of steel 2000 mm square. So this is the area of cross section. Area is being pulled with an axial force of 100 kilonewton, 80 kilonewton. So for example here I draw lah. You have like a bar of steel. Okay, so maybe they're being pulled 180 kilonewton. Okay, the area here is 2000 mm square. So what you need to do is you just use this formula. Sigma equal to force divided by areas. This is the formula that we usually do to solve this kind of question. Very simple. Okay, macam mana you buat? So you just, I have to padam this one. Okay, here you have the force which is 180 kilonewton though. Since I already mentioned that mostly kita when we calculate for stress, we will use Newton over mm square. So this is a preferable units to calculate stress. Okay, jadi force ni, since it is 180 kilonewton, you need to convert it into Newton. Jadi darab 1000 sebab kilonewton, you tukar Newton, you have to times 1000. Okay, so 1000 here means sama juga dengan 10 kuasa 3. Okay, that's why I wrote here 10 power of 3. And then you divide with the area which is given in the question. So this is the area of that bar steel. Maksudnya sekarang steel bar tu macam ni kan. So area cross section, if you cut it here, you pun dapat bulatan macam ni juga kan, sama je. Okay, that circle, the value, the area is 2000 mm ni lah. Okay, jadi you divide kan saja, you will get the stress because of from the force yang you pull out the steel bar tu. Okay, jadi stress particles dalam dia adalah 90 Newton over mm square. Simple. Alright. So this is example 1. Then we can go to example number 2. Okay. Example number 2, a black pier is 0.7 meter square. Okay. Jadi ini black pier, meaning pier ni like a column, tapi pier ni mostly lagi besar. And normally pier ni pakai dekat like tempat yang berair. Macam mana macam like jambatan macam tu, so we call it pier So normally if let's say kalau pier ni, normally you have a pier. So ini contohnya, ini pier. And you will have another column on top of the pier, smaller one lah. Okay, so column ni smaller lah, pier ni like bigger than the column. Okay, sorry, yes, pier ni bigger than column. So this is the column. Okay, so the pier size is 0.7 meter. So ini 0.7 meter darab 0.7 meter square and 3 meter high. And weight 19 kilonewton per meter cube. So if you see like 19 kilonewton per meter cube ni bukan weight dia, is actually unit weight. Okay, jadi this is unit weight of the pier. It is supporting an axial load of column 490 kilonewton. So on top of this pier there is a column yang axial load dia adalah 490. So daripada kolom ni turun ke pier 490 kilonewton. Okay, jadi you ada 490 kilonewton force acting on the pier daripada kolom. The load is uniformly spread over the pier so that the arrow show. Okay, gambar dia sepatutnya ada. Gambar ke? Tak ada. Okay, so I bagi gambar kat sini lah. Merely represent the resultant of the load. So 490 ni resultant daripada kolom tu lah. And then the question asks you to calculate the stress in the brickwork immediately under the column, which means that immediately under the column maksudnya betul-betul dekat bawah kolom ni, means dekat pier ni tapi dia transmit to the pier, jadi sampai betul-betul lepas saja 490 kilonewton ni lah. Okay, jadi we can simply calculate using the formula force divide by area. Okay, so that's why kita kira, sebab dalam soalan ni dia minta stress in the brickwork. Okay, betul-betul dekat bawah kolom. Okay, jadi kita kira stress in the brickwork. Okay, first, because we know that our formula is sigma equal to force divided by area, so we need to find the area. So which area that we talking about? It should be area of the pier ni lah, sebab betul-betul bawah kolom ni dia jumpa dengan this pier. Jadi this pier ni berapa actually area yang this force transmit, hantar kepada pier tu. Okay, so pier tu punya size lah. Okay, jadi 0.7 meter is actually in meter kan. So we need to convert it into millimeter. Therefore, so korang kena betul-betul understand about units ya. Units is very important. How to convert meter to millimeter, such thing Jadi kena tahulah. So we know that if it's 0.7 meter kan. So you know that 1 meter is equal to 100 centimeter. Okay. And 1 centimeter is equal to 10 millimeter. Okay. So maksudnya sekarang you nak convert to millimeter ni. Okay. Jadi kalau 0.7 darab 100 dia akan jadi 70, maksudnya 70 centimeter. And then you convert into millimeter, you darab lagi 10, so dia jadi 700 millimeter. Okay. Therefore, that's why ada 700 by 700 lah, because 0.7 meter by 0.7 meter kita convert, so we get this 490 millimeter square. Alright, then after that we can simply calculate the stress, force divided by area. Then we know that the force acting daripada column transfer to pier is 490 kilonewton. Convert it into Newton, okay, and divide with the area of the pier. Therefore, you dapatlah the value of stress in the brickwork immediately under the column. So inilah dia. Alright, and then for the second question, it asks you to calculate the stress at the bottom of the pier. Maksudnya betul-betul kat bawah ni. Bawah pier ni. Dekat bottom ni. Okay. So, semua ni maksudnya you kena kira force daripada atas, daripada yang ditransmit daripada kolom 490 kilonewton, include self weight of the pier, sebab betul-betul dekat base of this pier ni. Okay, jadi area dia adalah base of pier ni sendiri. Area dia adalah base of the pier. Susah betul bercakap. Alright. So, macam mana you nak kira? First, we need to calculate the self weight of the pier. Okay, so here is the calculation of the self weight. I rasa you tahu macam, I'm not sure whether you know how to calculate or not. Okay, but since dia dah bagi okay, ini atas dia bagi tahu ini adalah unit weight of the pier. It says it is 19 kilonewton per meter cube. So what does it mean? Okay, maksudnya lah 1 meter cube pier tu, okay, pier tu kalau size dia 1 meter cube, berat dia adalah 19 kilonewton. Okay, tapi sekarang pier tu bukannya size 1 meter cube. Size pier tu adalah 490 millimeter square. Okay, ataupun you kena tukar meter lah, sebab dalam ni kalau you tengok pier ni punya unit weight adalah per meter cube. Jadi bila kita darab kat sini, kita kena darab value yang, maksudnya unit yang sama Kalau kita pakai meter kat sini mesti meter lah. Tak perlu tukar 19 ni kepada millimeter, sebab memang I cakap stress I nak dalam per millimeter square, I nak dalam millimeter. But right now kita bukan nak calculate stress lagi because later on millimeter ni, this meter ni akan cancel sebenarnya. Dia tak ada masalah. So this meter cube per meter cube, maksudnya 1 meter cube adalah 19 kilonewton. Okay, tapi pier you size dia adalah 0.49 meter square. Okay, area dia. Tapi kalau you nak meter cube, maksudnya dia punya volume kan. Okay, maksudnya sekarang macam ni. This is 0.7. This is 0.7. This is 3 meter. So inilah dia, 0.7 darab 0.7 darab 3 meter. Okay, so that is the volume of the pier. Okay, jadi bila you darabkan dengan di 19, okay, automatic you akan dapat you akan dapat some value. 517 ni dah campur dengan 490 I think 27.93. Yeah, it is 27.93. Okay, so 27.93 ni, ini berat, berat pier. Okay, bila you darab semua ni, you akan dapat 27.93. So that is the weight of the pier. Okay, Therefore, you campurkan saja dengan this 490 kilonewton because this 490 kilonewton pun ada load juga daripada atas which is coming from the column. So sekarang you kena total up all the loads including the self weight of the pier and you will get value of the total load. Okay, total load maksudnya berat pier, berat kolom tu juga. Maksudnya load daripada kolom tu juga. And then simply divide it with the area again. Okay, so area dia masih sama lah sebab area base of the pier adalah 0.7 meter darab 0.7 meter tu lah ataupun 700 mm times 700 mm. Okay. So 570.93, don't forget to convert it into Newton. Okay, and then you will get 1.057 Newton over mm square. Okay, and I actually forgot that I need to tell you, I memang pakai 3 decimal places. Okay, so every calculation that you kira using calculators or whatsoever, you kena buat dalam 3 decimal places. Or if you prefer precision, you can buat 4 or 5 decimal, doesn't matter. Okay, but cannot be lower than 3 decimal places. Alright. We are done with example number 2. Let's move on to example number 3. Okay. Determine the tensile stress induced in the rod due to an axial load of 60 kilonewton. Okay. So, kita tengah kira lagi tensile stress. So, ini normal stress. Semua normal stress semuanya pakai this formula. Sigma equal to force divide area by area. Force dia mesti perpendicular dengan area. So, area kat sini, it says, dia dah cakap rod. And at the same time dia bagi diameter, which means you know that the cross section of this rod ni adalah circle round cross section. Kalau you cut it here, okay, you tengok lah, so sebenarnya dia adalah bulatan contohnya ya. So bulatan, you need to calculate the area of the rod because kita nak kira force divide by area. So to calculate that, I use the formula pi d square over 4, or you can also use pi r square or pi r square. Okay, sama saja, you will get the same answer. So pi d square over 4 I calculate, so pi I put d, the diameter is 20 mm. Power of 2 divided by 4, I dapat 314.2 mm square. And if you use pi r square, you will get the same answer, but radius maksudnya kalau ini 20 mm adalah diameter, so radius should be half of it lah, 10 mm. So pi darab 10 kuasa 2 dan you akan dapat 314.2 mm jugalah, power of 2. Okay. And then after that we can calculate the stress. Force divided by area, so 60 kilonewton convert into Newton darab 1000 and divide with the area of the circle ataupun round, kita punya round rod cross section tadi Okay, so I dapat 191 Newton over mm square. So simple saja. And then we have example number 4. Determine both the compressive stress in the shaft and bearing stress at the base of the column due to an axial load of 10 kilonewton. Okay, so here there are 2 calculations that we need to do. First is the stress in the shaft. Jadi stress in the shaft maksudnya dekat shaft dalam ni lah. Meaning to say area dia akan jadi area shaft ni So maksudnya shaft ni dia dah bagi size dia is 0.8 meter times 0.8 meter. Jadi kita tahulah shaft ni dia punya cross section, if you cut it here, dia akan jadi 0.8 meter darab dengan 0.8 meter. Okay. Jadi kita boleh calculate the area first. So stress in the shaft, tukar so meter we have to convert it into millimeter. Darab dengan 1000, then you get 800. You get 800 by 800, 640,000 mm square. That is the area of the shaft. And we just calculate the stress. So force divided by area. Jadi 10 kilonewton ni tukar kepada newton. Jadi 10 kuasa 3 newton. And divide with the area yang kita kira area shaft tadi. Then you get 0.016 Newton mm square. So we are done with the first question. And the second one, it asks you to find the bearing stress at the base of the column. So when you see there is a bearing stress ni bukan masuk kalau you nampak base of the column masuk self weight or whatsoever, tak semestinya Self weight tu kalau dia minta you stress sajalah at the base of the column. But when it asks for the bearing stress, it means that tak termasuk self weight sebab bearing stress ni is actually macam contact stress maksudnya anything yang in contact, contohnya macam this one contact surface yang you nampak. So base ni yang dekat bawah ni dia in contact with the one down here. I tak tahu apa nama benda ni. Drawing dia macam ni, jadi dia ada contact dekat sini. Okay, so contact ni dia kita panggil dia bearing. Okay, bearing. Macam contact pressure is a bearing pressure. Macam tu lah. So, bearing stress is a contact stress lah. So, dia ada contact between dia ada bearing maksudnya anything yang bersentuhan. Maksudnya ada yang contact with each other. Contohnya, if you see mostly lah, bila dia ada bearing stress ni, normally for example macam connection contohnya macam you have bolt and nuts. Bila you connectkan plates for example, so you connectkan plates, you have one plate here and the second plate down here, then you pun nak screw kan dia, then you put a what we call it, bolts and nuts So bolts and nuts, so kat sini dia ada bearing pressure, okay, between this apa kita panggil connector ni, maksudnya bolts ni dengan surface of the plate tu. Okay, jadi anything yang in contact, okay, dia akan ada bearing stress. Jadi bearing stress ni dia tak masuk self weight. Tapi kat sini surface dia dah berubah, which is 1.5 meter by 1.5 meter sebab dia kata at the base of the column. Jadi 1.5 meter darab dengan 1.5 meter. So area dia adalah 1500 darab dengan 1500. So you dapatlah value dia kat sini 2,250,000 mm square. And you just dividekan dengan force ni dividekan dengan that area. Okay, tak perlulah nak kira area, tak perlu nak kira self weight of this shaft ke, and then shaft ni semua tak perlu kira because of ini adalah bearing stress bearing stress tak termasuk benda tu. Dia just kira daripada stress yang being transmitted from above to that particular surface. Okay, jadi simply kira macam ni lah, dan you akan dapat 0.04. Kalau you pakai 3 decimal places 4 sampai 4 sajalah yang saya nak, 0.04 Newton over mm square. And now we go to the example number 5. Okay, determine the shearing stress induced in the rivet due to the shearing load of 40 kilonewton. Okay, if you see here, ini rivet ni adalah one type of connection rivet connection between steel steel with, macam contohnya you ada 2 steel plates, you nak connect it together, then you akan pakai rivet. Okay, jadi rivet ni dia dah tulis kat sini 20 mm finish diameter. Okay, jadi kat sini okay, you nampak ini adalah shearing stress. Okay, dia bukannya sigma ni lah. Okay, tapi sama je sebenarnya sebab formula dia masih lagi stress equal to force divide by area. Okay, jadi kat sini kita tak pakai sigma, it's actually tau lah. Is it macam ni? Yep. Ini tau. So tau lah. Okay, tau adalah shear stress. Kenapa shear stress? Because kalau you tengok dekat sini, okay, dia punya diameter dia bulat macam ni lah. 20 mm diameter. So you rivet kan dekat sini kan. Rivet tu dekat sini. Okay. Jadi surface ni, maksudnya that rivet tu, okay, dia parallel dengan force ni. Dia bukannya perpendicular. Bukannya force ni macam ni Kalau force ni perpendicular to that area, so dia barulah sigma. Okay, tapi kalau tau ni dia adalah parallel. Okay, dia adalah shear stress. Okay, mesti kalau shear stress dia P dia selari dengan area yang kita nak kira tu. Right. Jadi kita kira area dulu since area dia minta rivet, induced in the rivet. Jadi dia minta rivet punya area, maksudnya area bulatan tu lah. Bulatan tu, this is 20 mm finish diameter, therefore pi d square over 4, or you can also use pi r square without. No problem, boleh pakai. So pi darab 20 mm power of 2 divided by 4, ataupun you boleh pakai pi r square. Okay, pi darab 10 mm power of 2. You akan dapat value yang sama. And then kita boleh kira dia punya stress. So stress kat sini, maafkan saya terbuat dia as sigma. Okay, you use it as tau lah sebab dia adalah shear stress. So shear stress force divide by area. Beza dia kat sini, apa maksudnya? Beza dia just because dia punya force ni bukan perpendicular. Force dia adalah selari, parallel to the surface. Okay, jadi dia adalah shear stress. So force divide by area. So force is 40 kN, tukar kepada Newton and divide with the area, then you will get the value. Okay, 127.307. So if you look at here, I use 3 decimal places. We look at the next example, example 6. So here we need to calculate the stress of in the column. Okay, when it says in the column, so sama juga, you don't need to care about the self weight. First, as usual, kita kira dulu area of the column. So bila dia kata in the column, maksudnya dekat dalam column ni lah. So you ada dua size, two different sizes sebab cross section dia dah berubah. Okay, jadi kita kena kira dua kali. First for the top one and the second for the bottom one. So dia tak kata at the base of the column. Kalau dia kata at the base of the column, so therefore you kena masukkan self weight macam tu. But when it says that in the column, no need. Jadi kita kira area dulu. 100 by 50 mm for the first one. Then you get this is the area for the top column. And then just calculate the force. Masukkan saja 10 kN ni, convert it into Newton and divide with the area. Then you get this is the value of the stress. Okay, ini adalah sigma lah, maksudnya perpendicular. Okay, 90 darjah dengan surface, bukan dengan surface, dengan this area cross section. Kat mana-mana you potong kolom tu, cross section dia masih sama. And then for the second one, you kira area for the second one 150 mm by 100 mm, then you get this is the area. Then just take the 100 by 10 by 10 power of 3 newtons, because of it tukar dia into Newton and divide with the area. Okay, then you get for the second column below, it is 0.667. Okay, Newton over mm square. So that is for example 6. Okay, so this is our last example for today, because I think, masuk. Yep. So this one I akan proceed dalam starting pada example 8, I akan proceed dalam next class Jadi kita masuk example 7 dulu. Sama juga this one, calculate stress in the cylinder. So in the cylinder just calculate the area, crop, potong kat sini, you crop saja, then you akan kira area of this circle So area of this circle, pi d square over 4 or pi r square sama juga. Okay, but here you see it is 12.5 cm. As you know, 1 cm is equal to 10 mm. Okay, so kalau 12.5 cm maksudnya 125 mm. Okay, jadi you darabkan saja, masukkan dalam formula ni lah, pi times 125 mm power of 2 and divide by 4, then you get 12.271.85. And kira the stress, force divided by area, 5 power of 3 Newton, convert into Newton first and divide with the area that you calculated here, and then you will get 0.407 Newton over mm square. So for this chapter, okay, as I said tadi, memang sampai sini saja for our first class, because starting daripada example number 8, 9 and 10, kita akan buat dalam kelas tutorial. We will do it together. During that time, you can ask me any question. Okay, so hopefully all of you have the basic idea of stress, because for our next class, tutorial, kita akan buat sama-sama for 3 examples, and then in another lecture we will go to the strain and modulus of elasticity. Kita akan proceed lagi, hopefully kita habis dalam 2 weeks. Okay, thank you so much everyone and have a nice day.